Installing a ground fault circuit interrupter, or GFCI, breaker for a circuit feeding outlets within an open ground is permissible. GFCI breakers offer ground fault protection by tripping the circuit when a fault happens, even without a proper ground wire. This approach typically satisfies the National Electrical Code, or NEC, requirements for ground fault protection and is likely to pass inspection. You do not need to replace existing non-polarized outlets with older polarized ones. While polarized outlets are often recommended to enhance safety, current electrical codes do not mandate them. You can keep the non-polarized outlets, but it is important to label them clearly as no equipment ground. This labeling informs users that these outlets lack a proper ground connection. When installing a GFCI breaker, you need to substitute the existing circuit breaker with a GFCI breaker that has the same amperage and voltage rating. Be prepared to potentially extend the wiring in the electrical panel to accommodate the physical size of the GFCI breaker, which is often larger than standard breakers. If the outlets are malfunctioning, it may be necessary to troubleshoot the wiring connections or replace the outlets themselves. It is highly recommended to engage a licensed electrician for these tasks to ensure both safety and adherence to electrical codes. Ground fault circuit interrupters, or GFCIs, are crucial safety devices designed to protect individuals from electrical shock. They function by monitoring the current flowing into and out of a circuit. If there is an imbalance, indicating that current is leaking to ground, the GFCI quickly cuts off power to prevent injury. In older homes that lack grounding wires, GFCI protection is especially important. Here is some further information. Firstly, ground fault circuit interrupters, or GFCIs, work by monitoring the balance of electrical current between the hot and neutral conductors in the circuit. Normally, the current flowing through these conductors should be equal. Secondly, if a ground fault occurs, meaning the current is flowing through an unintended path to ground, such as through a person touching a live wire, the current balance is disrupted. The GFCI detects this imbalance, even a small difference of a few milliamperes, and quickly trips the circuit. Thirdly, this tripping action cuts off the power supply to the circuit within milliseconds, preventing a sustained electrical shock. GFCIs are designed to protect against the most common form of electrical shock hazard, which involves current flowing through a person's body to ground. Fourthly, GFCIs do not protect against overloads, short circuits, or line-to-line contact hazards. For those types of protection, standard circuit breakers or fuses are necessary. GFCI protection is required by the National Electrical Code, or NEC, in areas where electrical outlets are likely to be near water, such as bathrooms, kitchens, laundry rooms, and outdoor locations. This is because water significantly increases the risk of electrical shock. The NEC provides specific guidelines on where GFCI protection is needed to ensure safety. There are two main types of GFCIs. These include GFCI outlets and GFCI breakers. GFCI outlets are installed in place of standard electrical outlets and provide protection only at that specific location. GFCI breakers, on the other hand, replace standard circuit breakers in the electrical panel and provide protection for the entire circuit. When using GFCI outlets in an ungrounded circuit, they will still function to protect against ground faults. However, they will not provide the same level of surge protection as they would in a grounded circuit. The outlet will typically be labeled as no equipment ground. GFCI breakers offer the advantage of protecting all outlets and devices connected to the circuit, regardless of whether they are grounded or not. This makes them a good choice for upgrading safety in older homes with ungrounded wiring. It is important to test GFCIs regularly to ensure they are functioning correctly. Most GFCI outlets and breakers have a test button that simulates a ground fault. Pressing this button should cause the GFCI to trip, cutting off power to the circuit. If the GFCI does not trip when tested, it should be replaced immediately. The NEC requires that all new electrical installations and many renovations include GFCI protection in specified areas. Local building codes may also have additional requirements for GFCI protection. When installing GFCI outlets or breakers, it is essential to follow the manufacturer's instructions and all applicable electrical codes. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the installation. GFCI protection significantly reduces the risk of electrical shock, but it is not a substitute for safe electrical practices. Always use caution when working with electricity and avoid contact with live wires. Remember that GFCI devices have a limited lifespan and may need to be replaced periodically. The lifespan of a GFCI can vary depending on the manufacturer, usage, and environmental conditions. If a GFCI trips frequently, it may indicate a problem with the circuit or the GFCI itself. In such cases, it is important to investigate the cause of the tripping and address any underlying issues. When replacing a GFCI, be sure to purchase a replacement that is rated for the appropriate voltage and amperage. Using a GFCI with an incorrect rating can be dangerous. GFCI devices are sensitive to moisture and should be protected from direct exposure to water. Outdoor GFCI outlets should be installed in weatherproof enclosures. The use of GFCI protection has dramatically reduced the number of electrical shock injuries and fatalities in recent decades. By understanding how GFCIs work and following safety guidelines, you can help protect yourself and your family from electrical hazards. In older homes with ungrounded wiring, GFCI protection is often the most practical and cost-effective way to improve electrical safety. While it is always preferable to have properly grounded wiring, GFCI devices can provide a significant level of protection in situations where grounding is not feasible. Always consult with a qualified electrician to determine the best approach for upgrading the electrical safety of your home. Proper electrical safety measures, including GFCI protection, are essential for protecting lives and property. A GFCI monitors the current balance between the hot and neutral wires. A small imbalance, as low as 5 mA, indicates current leakage. The GFCI trips the circuit within milliseconds, interrupting the flow of electricity. This rapid response prevents dangerous electrical shocks. GFCIs do not protect against overloads or short circuits. Standard circuit breakers or fuses are needed for that protection. GFCIs are mandated by code in areas prone to moisture, such as bathrooms, kitchens, and outdoors. Two common types are GFCI outlets and GFCI circuit breakers. GFCI outlets protect only the outlet itself, while GFCI circuit breakers protect the entire circuit. For ungrounded circuits, GFCI outlets still offer ground fault protection, but not surge protection, and should be labeled no equipment ground. GFCI circuit breakers are ideal for older homes with ungrounded wiring, safeguarding all connected outlets and devices. Regular testing with the test button is crucial. The GFCI should trip and cut off power. Failure to trip indicates a need for replacement. New installations and renovations often require GFCI protection. Local building codes might have specific GFCI requirements. Always follow manufacturer's instructions and electrical codes when installing. If unsure, hire a qualified electrician. While GFCIs significantly reduce shock risks, they do not replace safe electrical practices. Caution is always advised when working with electricity. GFCIs have a lifespan and require periodic replacement. Frequent tripping suggests a circuit problem or a faulty GFCI. Investigate the cause and address any issues. Replacements must have the correct voltage and amperage ratings. Protect GFCIs from direct moisture exposure. Use weatherproof enclosures for outdoor outlets. GFCI usage has greatly lowered electrical injury incidents. Understanding GFCIs and practicing safety helps prevent electrical hazards. In older homes, GFCIs are often the best option for boosting electrical safety. Grounded wiring is ideal, but GFCIs offer protection when grounding is impractical. Always consult with an electrician for electrical safety upgrades. Electrical safety, including GFCIs, protects lives and property. When dealing with older homes and electrical systems, several key points must be considered to ensure safety and code compliance. The presence of ungrounded wiring, often found in older homes, presents a significant electrical hazard. Modern electrical systems rely on a grounding wire to provide a safe path for fault currents, preventing shocks and minimizing the risk of fire. In ungrounded systems, the safety net is absent. The National Electrical Code, or NEC, provides guidelines for dealing with ungrounded systems, and GFCI protection is a common solution. A GFCI device monitors the current flowing in a circuit and quickly interrupts the power if it detects a leakage current, which could indicate a ground fault. This rapid response can prevent serious injury or death. When retrofitting older homes with GFCI protection, it is essential to identify all ungrounded circuits and install GFCI outlets or breakers accordingly. GFCI outlets are typically installed in place of standard outlets in areas where moisture is present, such as bathrooms, kitchens, and outdoor locations. GFCI breakers, on the other hand, protect the entire circuit and are installed in the electrical panel. In some cases, it may be necessary to install both GFCI outlets and breakers to provide comprehensive protection. When installing GFCI outlets in ungrounded circuits, it is important to label them as no equipment ground. This informs users that the outlet does not have a grounding wire and that they should not use it with appliances that require a ground connection. Another option for dealing with ungrounded wiring is to replace the existing wiring with modern, grounded wiring. However, this can be a costly and disruptive process, as it may involve tearing into walls and ceilings. In some cases, it may not be feasible to replace the wiring due to the age or construction of the home. In these situations, GFCI protection is often the most practical and cost-effective solution. When working with older electrical systems, it is important to be aware of the potential for deteriorated wiring and connections. Over time, wiring can become brittle and cracked, and connections can loosen, leading to increased resistance and the risk of overheating. Before making any modifications to the electrical system, it is essential to inspect the wiring and connections for any signs of damage. If any damage is found, it should be repaired or replaced by a qualified electrician. Another important consideration when working with older homes is the potential for asbestos insulation. Asbestos was commonly used in electrical wiring and other building materials prior to the 1980s. If asbestos is present, it is important to take precautions to avoid disturbing it, as exposure to asbestos fibers can cause serious health problems. If you suspect that asbestos is present in your home, you should consult with a qualified asbestos abatement contractor. In addition to GFCI protection and wiring upgrades, there are several other steps you can take to improve the electrical safety of an older home. These include installing smoke detectors and carbon monoxide detectors, ensuring that all electrical outlets and switches are properly covered, and avoiding the use of extension cords as a permanent wiring solution. It is also important to have a qualified electrician inspect your electrical system on a regular basis to identify any potential problems. By taking these steps, you can help protect yourself and your family from electrical hazards and ensure that your home is safe and up to code. When performing electrical work, always disconnect the power at the main breaker before beginning any work. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. This is especially true when dealing with older electrical systems, which can be more complex and dangerous than modern systems. Remember that electrical safety is a serious matter and should never be taken lightly. By following these guidelines and working with qualified professionals, you can ensure that your home is safe and up to code.